We can start.
Hit it.
Okay, so welcome everybody to today's workshop. This is a workshop, so it's intended for you to be able to type along. And the subject is, as we see here, Docker containerization. So this is Docker containers, and my goal is to not sort of like in 2 hours cram in a comprehensive whirlwind tour of everything to do with Docker containers, but to hopefully provide the opportunity to issue some commands and sort of start to internalize it and understand the process on your own personal path to being able to use particular technology. So my name is Rob Fatland. I'm here with Kristen Finch. We're from UWIT Research Computing. And so we are supporting research computing across the campus. And a month ago, Kristen gave a related workshop on using the container technology on our new sort of GPU-based supercomputer Telecom. And so I'll give a reference to that material. And in addition, there's a couple of other Docker container lessons that are out there that I'll also be providing links to. But the main thing I'm trying to do in this, in my approach to this workshop, is to focus on you being able to type in commands and stuff like that. So minimal explanation, and there are 8 parts to this workshop today. The first couple will go by really fast, and then numbers 3 and 4 are pretty more in-depth hands-on. And then part 5 is going to be a summary of what we've done so far. And then parts 6 and 7 are sort of more advanced activities. And then part 8 is one more summary. So those are the 8 stages that I have set up for this workshop. Also, I want to emphasize that I'm in research computing. I'm also affiliated here with eScience Institute. And I'm sort of a generalist, and I'm also a sort of learning as I go. So I'm not coming to this as somebody who's been using Docker for years, and particularly the research aspects. I'm learning it. And in the process of preparing this material, I relied heavily on using a coding assistant. The one I used is built into Visual Studio Code, which is an innovative development environment. And it's provided by Amazon Web Services, and it's called QDeveloper. So what I found really helpful, I just want to mention this in terms of interacting with this QDeveloper sort of chatbot, is that this technology, this container technology, is kind of complicated. And so I would try and put together the ideas, and what I would do is I would type into the chat, I would type in, here's what's going on with this container aspect of container technology, and then I would get a reaction back from the chatbot. So that's indicated by this little diagram here where I have a hypothesis of what's correct, and the chatbot would correct that, and then I would change my hypothesis, and I would keep iterating that way. And I found it to be a really good way of reinforcing the concepts that go into sort of having a working sort of gut level understanding of what Docker does. So that's my plug for using a coding assistant. Let's see, I should probably hit the forward. Oh, okay. So these are the sequence of 8 activities. Activity number 1 is a hello world. And so that activity is encapsulated in the red oval at the top. So all you have to do is run that. But if you run this command, Docker run hello world, and you don't get anything back, it says, Docker, I've never heard of that. Then that means that your computer, which I'll refer to as your host machine or local host, does not have the Docker VM running. So the way we get that running on PCs and Macs is to start the Docker desktop application. So that application, when it starts up, creates a virtual machine inside of the host machine. And that virtual machine has all the guts of Docker built into it. And so that's what we need in order for that to register itself on the Linux command line. So if you're using a bash shell, you type in Docker, you should get something back. So I'm going to, a lot of this workshop will just be me switching over to Visual Studio Code and doing the activities. So I'm switching over to VS Code, and the font maybe is a little small, but I'll say Docker run local world. And I get a printout like this. So this is the quickest way to getting a Docker container running. All this text here is part of the activity. So a very quick narration of what happened when we type Docker run hello world. The word run is a qualifier to the Docker command. So Docker, CKER, is a command line interface to the Docker engine. And when we say Docker, it means, hey, Docker, wake up and pay attention to everything that comes after this. And run, some of this vocabulary, if it's new to you, I'll just keep repeating it until it starts to become second nature. So run means go find an image and create a container out of it, and then run that container. That's what the run command does. And then finally, we said hello-world, and that by default is the image that we want to work from. Now, we haven't done anything on our computer to create a hello world image, whatever that is. So what Docker does is it says, okay, is there a hello world here on this computer? No, there is not. So it says unable to find the image locally. And then it runs off to a website called Docker Hub, and it looks for hello world there, grabs it, brings it back. That's an image. It's not executable yet. Converts that image into a container, and it runs the container. And what that container is set up to do is to print all this stuff. So that's what that single command did. It actually went off into the internet and found an image, brought it back, converted it to a container, and ran it. So that's the first activity. 1 down, 7 to go. The second activity is also on this page, which is that if you would like to work with the content for this workshop, then you can use git clone to pull down the material. And so that's the argument on the screen there, git clone, and then https github.com. My username is Rob Fatland, and it's called Docker Workshop. So I'm just going to sort of pause for a moment to give people a chance. And that should create a directory in your local directory. So sorry, in your home directory, if that's where you run this from. And that Docker Workshop directory is part of the activities, but it's actually more parts, later on parts of the program here. So steps 6 and 7 are particularly dependent on that. But also within that GitHub repository are some documents. There's a Q&A document and kind of a reference document. And then there's the instructions for the commands that we're going to be issuing in the various steps. So I think that's called workshop instruction or something. Okay, so let me just do the same thing. So here's my home directory. I don't have very much stuff here. I'll say, oops, git one. And you can also just go to GitHub and follow along there. Okay. So there's my Docker workshop folder. And that's activity 2 down, 6 to go. And so now I'm going to start paging through my presentation here. Okay, so here's a slide that I just talked over without actually going. Oops. Okay, now we're in part 3. So there's 3 important nouns in Docker container magic. The first important noun is container. That's something that executes. Image is something that acts as a template for what executes. And then there's the third noun, which is Docker file. So a Docker file, as you could say, it's sort of like the beginning of a recipe, and it's usually associated with a couple of other files. If you're on your way to building a container using the Docker technology, then you're going to want to start with a Docker file, and put that into what's called project folder. So there's a project folder, inside of that is a Docker file. So what we're going to do is make the simplest possible Docker file and use that to create an image and use that to create a container. So the simplest possible Docker file starts with the word from, and that's required element of Docker file. That's obviously the only thing that's required. And from means go and find this existing Docker image as your basis, and then do extra stuff to it as directed. So what this is going to do is it's going to go and get an image from, again, Docker Hub, and that image is going to be a basic sort of Debian Linux operating system. And that comes along for free, and then it's going to include Python version 3.11. And then it's going to include a slim version of that Python, which is not the full-blown Python we sold with the C compiler, but just sort of a good small amount of Python stuff. So that's what we are doing when we write from Python :311 slim, is we are going off and finding the image that's the basis for what we're going to continue to do. One of the mysteries of containerization is knowing which version of the modules and the libraries and images that you're going to be installing. And the way that I came up with 311 is I just ran Python locally on my localhost, on my host machine, and said Python version, and it said this is Python 311. So now I compile with my local Python. And that's in the context of being a developer, where you might be developing in your own laptop, and then you're going to be transferring that over to the container component. Okay, so we're going to create a project file called foo/fu, and we're going to go ahead and build. So now I'm going to go to the next page, which has the actual command sequence, and I'm just going to type through these commands, and hopefully that will be enlightening on certain areas of it. So I'm going to start off by going to my home directory and creating a project folder called foo. So I say cd, make it to foo. And then I'm going to create a Docker file, say echo, and then from Python :3.11 slim. Is that what it was called?
Yep.
And I'm going to echo that, and I'm going to echo it into a file called Docker file. So Docker file is not only a man, it's also the default name of that file. And I can look at Docker file and make sure that it reads correctly. So far, so good. So I have a Docker file in a project directory called foo, and I'm going to be creating an image called foo-image. So let's list the images that are currently on this computer. So I say Docker images. Oh, and hello world is already here. So now we have Docker images is a command that lists all of the images that are on this computer. And since I've already grabbed hello world, it shows up. Now I can also list the existing containers on this computer. And you do that with sort of a portmanteau command. It's Docker PS, my process status. If I say Docker PS, there's nothing here, but that actually only is going to list Docker containers that are running. If I say Docker PS-A, it will list the hello world container. So again, we have image container, and now we're listing that hello world container, and we can delete it if we want to, but it's not going to much, so I'll just let it stay there. Okay, so where are these things? Kind of steal my own thumb. Where is the image? Where is the container? It's got to exist somewhere. And the answer is, don't worry about it. Basically, the idea of the container technology is inspired by a bunch of principles, and one of them is sort of separation of what you got to worry about and what you don't have to worry about. So the Docker VM is sitting there maintaining a memory space where all these containers and images are stored. And we can list them and stuff, but we never actually go and interact with them on that spot. Okay, we're just there in the Docker group. Okay, so what was I doing?
You're going to build a food image.
That's not build a food image. Okay, so we say Docker -t. -t is a flag in its tag, so we're going to give our image a tag, and then we're going to tell it. We're going to tell Docker build what directory to work from, and it's the directory that we're currently in. Which better be. Well, I didn't go into the food directory. Okay, now I'm in the food directory, so now I can tell it to use this directory. So I said Docker build -t image, and then dot. And that dot has to be there. It means work from this directory for all the instructions on how to build this Docker image. Fail to read Docker file. Open Docker file. No such file directory. That's because I created a Docker file in the parent directory instead of in. So I'm saying move. So now I've actually got Docker files sitting in the directory, and I'm run that command again this time. Okay, so it works. So now if I say Docker images, there should suddenly be an image here called food image, and it sure is. So success. And now let's create the Docker container from the Docker image. And that's going to be a separate command that's called Docker run. So Docker run. And what we want to do is we want to run the image that we grabbed. Remember, it's Debian Linux plus Python. And all we want to do is jump into that image for that container, sorry, when it's running. And as it's running, we're going to pretend that we're in a Linux environment. So that's the end consequence of this activity, is ending up inside of a container in a little fake terminal, pseudo terminal. I'm just going to check the command. So it's Docker run. IT means interactive pseudo terminal. Who image tells it what image to work from. And then finally, we have an optional final argument, which is what command to run when you start that container. The command we're going to is bash, which is creates the interactive bash shell. Okay, so I've run this. There's somewhat reading text.
Can you try control plus, hold control plus plus plus?
Okay, so now hopefully my text is more readable. So now I have a new prompt which says root at and then a bunch of hex characters and then a pound sign. If you're familiar with the Linux operating system, you know your prompt is usually not a pound sign, and if it is a pound sign, that means you're root. So I'm the root, the most powerful user in this container. Okay. And so I have a command line here, and this means I claim that we are actually existing on a terminal inside of a running Docker container. I can say ls, and it lists, oh my gosh, it lists the root directory stuff. I can say pwd, I'm at the root of the file system. And I can say cd home, list what's there, there's nothing. So, okay, obviously I can issue Linux commands. And I run Python. Let's try it. I'll run Python command, and I get the Python prompt. I say x3. Okay, so I can run Python. I have Linux as container. Great. I'm going to quit Python. I'm going to say exit, and that's going to halt the containers. If the container is no longer running, it doesn't. Let's check that. So we say live. Docker, yes. And then -a for all of the containers. And here we find there's food-image as well as follow. So we're in good shape. We've created a Docker container and its associated image that has the bash shell and Python. Okay, backing up to the same slide here. I have this command down here. See, I can't really highlight this. So after we did this experiment, we have finally Docker container prune. And what that does is it goes and deletes all the containers that are not currently running. So from that, warning, this will remove all stopped containers. Sure, we can do that. So now I've deleted the container that I was just using. Say Docker ps-a again. Now there's no containers whatsoever. I deleted hello world as well.
But you still have the image.
Well, let's find out. Docker images. Yep, foo image is still here and hello world is still here. So I can recreate those containers if I was something. So it's kind of nice to have the images as an intermediate step between the Docker file and the running container. Once you have an image, you can make as many copies of it as you like. I mean, sorry, you can use it to spawn as many containers as you like. Okay, what's next on the hip row? The next thing that I did was I removed the image. So the command there is Docker RMI for remove image, and I removed the image from the image too. Docker RMI, and then if I say Docker images, I can still see hello world, but the image is gone.
How much should I be cleaning up? Is this gonna take a lot of storage on my laptop?
This is not going to, these things have a size that's on the order of 10 megabytes, something like that. So it's not taking up a huge amount of room. It's a good idea to keep things cleaned up, tidied up, and current. And a little bit further in the deck, there's actually a command that will show you what the volume sizes of the various objects that you have in the Docker VM. Yes.
Will it still be rather small even if you install a large number of dependencies inside the Docker?
Well, here's the interesting thing about Docker. We have this sort of two-stage build process. You can go off and get a bunch of dependencies, for example, let's say weights for a model. In the stage from going from the Docker file into the image. So the image will be very large, based on what you grab. Or you can actually defer that to the container build stage so that the image will still be small and then the container will be loaded up by the weight file. Does that make sense? Okay, so that's halfway through step 3. And this is the rest of this. Okay, so now we're really digging into it. What we're going to do here is we're going to do exactly the same thing that we did on the previous page with slight variation. And I'm doing this to hopefully sort of like revisit the commands and sort of by repetition start to internalize it. So the first block of these 4 commands is to go in and build the Docker image and then to run it. So it's exactly the same as before. But this time when we're inside that running container, we're going to leave an artifact that shows that we've been there. So and if we were to try to build this stuff and we hadn't done that cleanup stage, then it would say, I can't build this stuff because there's already something here with that name. Okay, so I run those 2 commands, the build and the run command. I've created a container and I'm now logged into that container. I have my root prompt. I can even say, who am I? And it should say that I'm root. So far, so good. So we're going to do something that's considered sort of sacrilegious in Linux, which is we're going to create a file in the root directory. So I'm going to create a file that's going to be 1 line of text. It's going to be echo. This is contain file. And then if I say ls, there's container.text. And it says this is the container file. Okay. Let's say I did slightly different version of that in the instructions. Now I'm going to exit from the container and say ps. Oops. Docker ps. It doesn't show up. Docker ps-a, it's still there. And so now I'll try and make the point that I was going for with the second page of activity, which is when you start building containers, you're like, okay, I've got a container here, and I've got another container over here, and once and then if I go into a container and I start making changes to it, and then I leave the container and go back in, will those changes still be there? Like, does it remember somehow? And the answer is yes, it does. So containers that you modify are constantly being saved into that internal Docker virtual machine, and their state is preserved so that if you leave and come back, you'll find what you've done. And that includes things like bringing in data sets or installing modules, installing libraries, all the kinds of crazy stuff that you want to do. You can sort of do that in this manual way and it has a memory, it will retain what you do.
But that file that you made, container.txt, if you ls where you are now, is not in there.
Right. Where I am right now is in the food directory, and the only thing that's here is Docker file. So you're absolutely right. When we did that echo, we were doing it inside the brain of the container. And that's independent of the operating system that we're working in the host, which is right now in this food folder. Okay, so we're going to need to restart the container to see if that indeed that artifact is still there. In order to do that, because we didn't tag it, we need to find out what the system named our Docker container. So we do that with the ps-a command. So I'll say Docker ps-a. When I run that, it tells me, yeah, here's this container. It's built from the foo image. And when you started it, you ran bash, and you exited about a minute ago, and it's called Nice Nightingale in my case, different from you. So now we're going to learn a new Docker action, which is Docker start. And we should be able to say, let me just check. Yeah, we want to make it -AI means attach the terminal to it, make it interactive, and then I'm going to write Nice Nightingale. So if this works, then I'm restarting a stopped container. There I am back on the command line. I'm still on the root directory. I can say ls, and there, sure enough, it's container text. And when I look at its contents, it says this is the container file. So great, we've established to our own satisfaction, or at least I have, that the container has a memory, change things, it keeps. Okay, so I'm going to exit out of this.
Sorry.
And then here we are on Docker file, so let's look at the instructions. The last thing that I did here, whoops, is at the bottom of this slide, is I ran Docker RMI and got rid of foo-image, and I ran Docker container prune. But I actually, I think I did those two in the wrong order, because if you try and remove an image while its corresponding container still exists, it complains. So let me just try that. Anybody else try that?
Yeah, it doesn't like it.
Okay, so let's do Docker container prune first. This will remove the stock containers. Okay, so it does that. And now I should be able to do Docker RMI foo-image. And it's not, it doesn't mind now. And I can say Docker images, ain't nothing there except hello world, and Docker, oops, Docker ps-a. And if you want to grab the course materials, you can get clone on this.
Oh, thank you.
Okay, so that's activity 3. 3 down, 5 to go. And 2 of those 5 to go are summaries. So, but actually, the next one is also in the same vein of kind of repeating these Docker commands to internalize them, plus one more step in the sort of Docker ecosystem. So let me go back to my slides. Page. This is part 4. It's called bind mount. And I'm going to take a deep breath and again jump ahead a little bit in my narrative and say that one of the concepts that motivated this whole containerization movement, you can start to see that these containers act as these little hermetic universes that can be given jobs to do. Right? That's sort of the point of containers. So they were thinking about this and they're like, okay, let's make the container exist in such a way that it's not really sharing like the file space with the main operating system, but it is borrowing some of the Linux kernel so it can, not be gigantic. But it's not sharing data space, so it's isolated. So isolation is a key feature of Docker containers. But if you make them entirely isolated and you're doing something interesting inside of that Docker container, then you're going to want some way of getting stuff out. So there's this duality of being isolated and hermetic, but also being able to connect to other stuff. And there's 3 things that are in particularly important about connecting. One of them is that if you're going to use your container, let's say as a web server, then it needs to be able to touch the ports on the host machine. And so ports are something that you can connect a Docker container to the outside world. So ports is the first of 3. The second thing is volumes. So in other words, disk space. And that's what we're exploring in part 4 here. And then the third thing is in addition to a Docker container being able to write a file and then having you be able to see that from the operating system, from the host operating system, that's what the volume mount is about. The third thing is a network so that 2 different Docker containers can talk. So volumes, networking, and ports, those are the 3 aspects of breaking out of the hermetic Docker container into the outside world to interact. Okay, so bind mount is the second of those 3. It's volumes. It's using a volume that's both mounted in our local host file system and also mounted in the container. And it's the same thing. So it's just mount. Okay, so we're going to go back into the food directory and we're going to add another line to our Docker file, which is work.dir app. That's nice. I wonder what that means. So let's go back into there and work.dir app. So here I am. I say echo work.dir app onto the end of. So it's greater than is the concatenate at the end of.
Like an append.
Like an append, exactly. Although APP is actually stands for application. So traditionally your application code sits in your Docker container in a folder called app. Okay. The funny thing is I have no idea why we're doing this, but I'm sure it'll become clear in detail. So here we are in the food directory, and let's see what the instructions say to do next. Okay, build the image. Oh, and then we have to make a directory called DW data, that's Docker workshop data. And this is still, we're not going into the Docker container yet. This is back in our host operating system. We need a directory called DW data. So I'm going to go ahead and build the foo image again. Set Docker build -t foo image dot. Work their relative path, relative to unexpected results. I'll write this on there. It's not really bad. Okay, so I'm gonna go back to my home directory. I'm gonna say make directory Docker workshop data. And then inside of that directory, I'm going to make a file which says this is the host machine. So I'm going to say echo. This is the host machine into tilde / Docker workshop data / host.txt. Okay, so this is the host machine. There's a file sitting in my regular operating system, my regular file system, in a data folder called DW data. And that file is called host.txt. And it says this is the host machine. And now I'm going to go back into the food directory. I'm going to say Docker images. Now, the last command on this page is Docker run, so we know we're going from an image to a running container. -IT again is Mixit, the interactive pseudo terminal. -V is now mapping a volume on the left-hand side, which is on our host machine, to a volume on the right-hand side, which is called /data. And then we're giving it the image, and then we're going to run bash. So we're back inside the container. Okay, so if this behaves as we hope, then we're going to find ourselves on the command line as root inside a container in a folder called app. So apparently that's what workdir does, is it creates a folder called /app and puts us there. If I say ls from app, there's nothing here. But if I say ls ... there's a folder called data. So let's go to cd / the home directory, and then let's go climb up into the data subfolder and say ls. Oh, and there's a file here called host.txt. So we're inside the container and we're seeing a file that we created in the host. Okay, now I'm going to say echo. This remark is from inside the container. And we'll put that into container.txt. So now I'm back on the root prompt inside the container. I've done everything I needed to do. I checked the file that came from the outside, and I created a file that came from the inside. I'm going to exit this. And I'm in the food directory, so I'm going to go back to my home directory. And then I'm going to go to DW data and say ls-al. And there's two files here. And the second one, we already made the host one, so now we're going to look at the container.txt file. And it says this remark came from inside the container. So again, I claim I've proven to myself, and perhaps you, that we have created an overlap between two data spaces, one of them inside the container and one of them outside. Okay, so that's sort of, for me, like an emotional weight lifted, because I'm getting to this container stuff and everything seems to be happening inside the container, but now we've broken a hole in the wall and we can, pass information in and out. So that's a key part of, yes.
Can I say one thing? So I was following along, but I'm not using my home directory as the directory that I'm working in.
Okay.
So when I mounted the DW data directory, I had to, in your command at the top there, where it says squiggle and then /DW data if you're not in your home directory. First of all, you have to change that, but you should put ./DW data. And that's how it worked for me. So it says like here.
Right.
And then my Mac also asked if it's okay for Docker to see into my documents directory, which I said yes.
Okay.
Just in case you're in a different, you're following along, but you're doing it slightly differently. Yeah, okay.
Cool, thank you. Yeah, tilde is your home directory. If you're going elsewhere, then you're gonna have to dot, which means this. Okay, next. So bouncing back to the deck, it appears that we've done the last part of the bind map activity. Okay, so the narrative here just says we can navigate to /data to confirm those text file here. So this is just the stuff I just did. And then okay. So part 5 is going to be some of the backstory here. So hopefully this will be of value and interest. Any questions at this point? Okay.
No questions in the chat either.
Excellent. I mean, that's either a good thing or a bad thing. I choose to interpret that as a good thing. Okay, so we're going to page down. This is a long page of text. It says read later. So since you have this deck, you can read this later. But it gives an inspection and some debugging ideas and da 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 da. But the main thing I wanted to say is that if you've heard of something called Flask, it's a Python web framework, and you can import Flask into the top of your Python file, and suddenly you can talk to the internet. In fact, you can interpret a internet call as an API call to a Python function. So Flask is something good to be aware of. It's used, but not dwelled on in part 6 of today's workshop. See if there's some other things that are too wordy to read. Right, so one of the things that I was mentioning earlier was that Docker comes out of a bunch of design principles, and one of these is portability. So being able to compute anywhere, supported by a Docker ecosystem. It's not just, oh, I can take my container and carry it over to your computer and run it there, but there's this thing called Docker Hub sitting out on the web that is happy to accept images and save them for me, and I can use them later and pull them later, or I can tell you what they are, and you can pull them. So the Docker Hub is a big part of the ecosystem. And you were saying Aptainer doesn't have a corresponding thing?
No, not as nicely maintained. I think that they tried to get one to catch on, and then no one used it. So all of the images there are quite old. I would say Docker Hub, it has even absorbed some of the other specialized container repositories like biocontainers, for example.
Okay.
They have a profile on Docker Hub. So I would just start there if you're looking for any containers that you might want to use elsewhere.
So Docker Hub is the greedy octopus.
You could say that, yep.
Yeah. Okay, and so that down at the bottom, I have why 2 or more flavors of container, and that's just sort of like a competition-free marketplace kind of thing. I think that somebody saw Docker and said, hey, that's really cool. Let's do our own version of that, and that was called Infinite. But anyway, that I think eventually became Aptainer.
Singularity.
Singularity, thank you. Black hole singularity. So yeah, the different kinds of containerization technologies, way down in the weeds, details are different. The security perhaps is different. And so that's why there's this, multiple ecosystems out there. Okay, and I've already answered the last question. So let's see, and I mentioned that Kristen presented on Aptainer. Also in the README file, and I think in elsewhere in the documents like repo, I refer to a lesson, a containerization lesson for Docker that was created by Naomi Alterman, who's an educator here at UW. She used that to teach about Docker for a material science course, for a data science course in the C544. And then there's also the Carpentries is a sort of software and technology learning organization, and they have a tutorial. So if today's tutorial is sort of a good start or a bad start, you have these other resources to go off and explore as well. And then in addition to just typing in, show me a Docker tutorial in the search. Okay, so that's that. Here's another read later thing. But I'll read the first sentence here. It says there are 3 central nouns in the Docker ecosystem: Docker image and Docker file, image and container. And then the Docker file is part of a project folder, as I mentioned before. And data access we saw in bind bound part 4, connectivity. What we haven't really done is taken advantage of that sort of project directory structure and put additional stuff in there. So that's what we get to in the last 2 activities. And then I started just writing down all the doctor vocabulary that I do or do not understand. The second one I'll just mention really quickly. If you're not familiar with that acronym CLI, that simply means command line interface. So every time we type Docker or something, we're using the Docker CLI. The Docker desktop, as I mentioned, is what starts up that VM. I don't know how that's done on a Linux machine, but there's some maybe different approach. And then the Docker workflow simply refers to this notion of starting from doing a pull of an image from, say, Docker Hub into creating a container, and then running that container, and then halting for some. Okay. This is the duality. I said I was going to steal my own thunder, so I've already kind of talked through this. But the 3 points of breaking through the hermetic notion. By the way, you're not allowed to say that a Docker container is a virtual machine. Apparently, that's technically not correct. So I would apologize you for sort of treating it like it was a virtual machine. Okay, so we have ports and volumes, and
Is that more like Chroot?
Chroot. Yeah, I don't know. I don't know what that is.
Where you change the root. So now you're in like your own protected space.
Oh yeah, I think it's definitely would be analogous. And see, this is where I've like hit the wall. I don't know. I love not knowing. But this is the point at which it's pulling out the coding assistant and saying, is containerization sort of like true? And then having that sort of come up with a clarification. That's what I'm returning to.
Just a thought.
Let's see. Okay, so we're getting to the container headspace. Okay, so I'm going to just keep on rolling here.
It is 1:55.
So we're
Halfway through.
halfway through more.
Yeah.
Yes. Okay. Well, let me go even done sooner. Let's see. So isolation, I've already talked about. Abstraction, I've already talked about. Multiplication, taking one image and creating a whole bunch of containers. And then the resilience I've also talked about. So, okay. Sort of touched on a bunch of these topics. One thing that sort of will tend to occur to us as we get used to this technology is you could break up a task into, let's say, workflow data analysis into multiple subtasks, and then you could assign those to different containers so that the amount of work you're doing within a container is sort of localized, and the thing that it does is sort of constrained. So separation of concerns. This is a diagram that I started to make about the guts of the Docker desktop VM. That's that pink box over there. With a bunch of containers, a bunch of images, and since it's in a box, you don't have to worry about things. Okay.
I would say from experience that the Docker desktop VM it continues to get better over time, but it is a very costly program, I think, to run on your computer sometimes, especially if you do have those containers with a lot of dependencies. But essentially what it is, it's just a graphical user interface to see, just like he was running the Docker PS-A or the Docker images, it has different tabs where you can see all of your containers, all of your images, and now I even see that I have a bound volume, the DW data. So it's a graphical user interface where you can do almost all the same things that we're doing in the command line, but I wouldn't recommend it. I would recommend to do the command like you're showing because it's just streamlined.
Cool, excellent, thank you. Okay, so this is an explanation of what happened when we ran the Docker run hello. So we're going pell-mell through the last couple slides to get to activities 6 and 7. This is again emphasizing that we don't worry about where things are on the local host because Docker manages that. And then there's this command docker system df. So let's just for fun take a moment to run docker system df on the command line and see what we get. And df is the Linux command stands for disk free. So it tells you how much disk is available. Here it's being used to tell you how big the volume is. 15.3 gigabytes for the images.
Oh, that's in your cache. My cache is a lot smaller.
No, my cache is huge compared to that. Yeah, 20. Well, I'm gonna look up how to do this stuff because that was like leftover stuff from previous.
Yeah.
Okay, so there's a little bit of another like command line look into the.
Yeah, I think there's ways to clear the cache and then also deleting some of those images.
Right, and the cache is there to sort of save you time so you don't have to re-download things.
Yeah.
Okay, so let's see. This is the last part 5 slide. And then we get to start helping with part 6. So Docker run versus Docker start. So we were using Docker run to launch from an image into a running container, whereas Docker start is just simply taking a stopped container and restarting it. Okay, I think there's nothing to beat to death here. I'll just continue on. So that's the end of part 5, and now we have left to build a 2-container configuration. Those will be 2 containers that talk to one another. And then the very last step is to build a implementation of ResNet, and then I have some final summary and conclusion. Okay, so container duality, isolation versus connection, provides for creating networks defined within the Docker VM. We have multiple containers on a single host that can intercommunicate. In this example, we have one container that acts as a front end for a web app. So it's facing the user. And then the second container is the back end, and that is going to be evaluating a positive number of user types and tell us whether it's a prime number. So this is a very simple toy example. Both containers will be using the Flask web framework, which I mentioned a minute ago. And that's to communicate. We're running both of these containers on our host. And so when they start running, they'll be listening on the front end, will be listening on port 8080. So we simply type in localhost :8080 on our browser address bar, and that will be the test. Okay. Let's go on to the actual instructions. And now I'll just start coding along here. Docker network create prime net. So now we've created a network that doesn't have anything to do yet, but it does exist. Docker network. Okay, so my prime network already exists. I can say Docker network move prime net. It's deleted it. Now I'm just going to create it. Okay, so that seems to work. Go back to the Docker workshop home directory. And I notice here that there are two directories called prime checker and prime frontend. So those are going to be the names of the corresponding images. Okay, I'm just going to build. Okay, so these instructions are a little bit abbreviated because they're not properly moving to the right directory. So the instructions and other document might be more accurate, but I'm just going to remember that I'm doing builds in both the prime checker and the prime frontend directory, so I need to travel there first. So, Docker build prime checker dot cd dot to back up. And I'll go to prime frontend. So again, I'm just creating images here. Okay, cd dot, and I'll say Docker images, and I'll make sure that both of those images are here. So prime checker is here and prime frontend is here. And let's say Docker network LS. There's a bridge network listed, a host network, there's a null network, and then there's the prime net network. Okay, so now the next thing we do is go to, doesn't matter where we go, we simply say Docker run, and then you say -d, and then we give the name of the source image, and then we give the name of the network to use, and then we also give the name of, oh, there we go. Let me try that again. So the fifth command on this slide begins Docker run -d, and -d means detached. So that means run without any kind of interactivity. Just sit there and run. That's what you do with the web app. And then there's the flag --name, and then it says prime API. So that's the name of the container. It's going to be prime-API. And then it says, be aware of a network called PrimeNet, and then use the image. The last argument here is the default of what image to use, which is called prime checker. So this is not the front end, this is the back end. It's tricky as I have to remember.
Do you want me to read it to you?
No, it's okay, I'm fast.
Okay.
Okay, so I managed to get that out without any errors. So now I'm running a container called Prime API, but it does not talk to the. And so there's a -P 8080 colon 8080 here. And that's a piece of information for the process to use that says that in the localhost machine, port 8080 is associated with inside the Docker container port 8080. So it's just a straight across mapping. So that when we enter something in our localhost in the browser window, which references port 8080, that gets pinged into the front end Docker container. So now if I say Docker PS without the -A, it should list both of those applications that's running because they're running in the attached. So we're all set. What I'm sort of glossing over here, and you can dig into this at your leisure if you're interested, is if I go to, say, prime checker directory and say ls, now suddenly there's 3 files here instead of just Docker file. So the other 2 files that are here are app.py, which is the Python code for the web application. And then there's a list of libraries to install in the build process. And that libraries list is called requirements.txt. If I look at its contents, there's only one library that I need for this program, which is Flask, which is the web framework, Python web framework that we use to do the message passing. So that's what's in requirements.txt, but we haven't looked at the Docker file. So let's take a look at the Docker file for a second. And that's all of a sudden very complicated. It starts off in a familiar way with the from command. So start with this starting point image, and then set the worker as app, that's fine. And then it's doing some voodoo here that we'll get into more in the last activity, the one after this one. But I'll just mention briefly that it says expose 5,000, and it doesn't really need to do that, but it's sort of doing it as documentation. I mentioned we're going to have 2 containers that are going to talk to each other, in addition to the browser talking to one of those containers. So when the 2 containers are talking to each other, they're using port 5,000 to talk. And that's just sort of like somewhere over here, port 5,000. Okay. So that's a quick sketch of what's happening with the guts here. Let's actually test it. Go back to here and escape my presentation, bring up a new browser tab, and then say http://localhost:3080. And hallelujah, it works. There's a web app sitting here that checks prime local. So if I type in 17, check it. Parent 17 is prime. The 1 is not. So, so again, the arm waving narrative here is that we are interacting with our web browser and typing in localhost 8080, which is just connecting to port 8080 and sending a ping there. And the front end application is receiving that and it's saying, oh, somebody is using our web app. I'll send back a bunch of HTML. So that HTML is sent back and it describes how to set up this page with this button in this window. And then when we click on the check button, that HTML is also explained to the browser how to send another message back saying, actually, I want you to check this number for whether or not it's a prime and tell me that back. So we have a sort of a bucket or a back and forth communication going on between the browser and the front end web app and the thing that actually evaluates whether a number is prime. So far, so good? Okay. So let's see. Go back to slideshow mode. Okay, so that's part 6. Let's see if there's more on part 6. So there's a read later page here, again, more fine print, which basically kind of reviews what I've just been waving my arms and explaining, or trying to explain, with the ports and intercommunication and how stuff is going back and forth. The necessity to build web apps, if we're sort of in an academic environment and we're doing research and we have data sets, that's really, you're not, well, at least my first thought is, oh boy, I got to create a web app. It's more like, oh boy, I have to get some kind of library in here that can do a FOIA transfer. So My point isn't so much aren't web apps great and isn't Flask great. It's good to know about. It's good to know about because then you sort of have that as an option to go if it comes up. But more to the point, we have two containers that are coordinating different activities and communicating. So that's kind of what I was going for with building out this activity. And that brings us to our last one with a final summary to follow. So this looks like it's going to be sort of an hour and a half long, something like that. I'm not sure quite what the time is, but I think that's a reasonable amount of time. So there's back in 2015, there was an annual competition to identify images, and this new entry came in called ResNet, Residual Network, or Residual Neural Network. Familiar?
Yeah, it's residual network.
Yeah. And so that was kind of a breakthrough in technology, and it won the contest. And so since then, it's been sort of like a milestone in the history of machine learning and AI. And what I wanted to do with this last activity was kind of look a little bit more broadly into the ecosystem of containerization, but also into the sort of world of hubs. So I put this material in a repo on GitHub, and perhaps we're familiar with using GitHub to manage software. We've been talking about how Docker Hub is a place where images can get thrown and stored and then pulled at a moment's notice. Hello World was pulled because it wasn't found locally, for example. So there's GitHub, Docker Hub, there's Binder Hub. I don't know. That's not worth going into. But then there's a place that's also another hub, but it's not called a hub. It's called Hugging Face. Right? Is anybody familiar with Hugging Face? Okay. So Hugging Face was a company. It started off doing chatbots, and then it kind of pivoted into ML about 7 years ago. And but it's the de facto hub for data sets and models in the world of machine learning and artificial intelligence. So you can stick stuff up there, and then you can pull data sets down, and you can pull models down and stuff like that. So that's what this activity is around, is about connecting a container to Hugging Face and being able to create yet another web app, because web apps are interactive, so it's kind of more fun, just calculating 100 digits of pi. So the web app is, in this case, going to run again in our browser. I think it's port 8081, so there's no collision, the port number. And all it's going to do is sit there in your browser and wait for you to upload a file, an image. So you have to find the image. And then you click on a button, and it tells you what it thinks it is. So that's our goal. We have 3 commands down here at the bottom of this page. Let me make sure I haven't missed anything. Oh, so yeah, ResNet fits in a modest container, at least the scale of ResNet that we're going to be using, which is called ResNet 50. The 50 refers to 50 layers of neural network. It's been already trained, it's pre-trained, so we'll be just pulling that data set down. That's about 100 megabytes. So there's a little bit of a web traffic to set this up. And when you do so, you end up with 26 million weighting parameters for the neural network. Okay, so I'm just going to go through these 3 commands. First, I'm going to the ResNet classifier. And here in the ResNet classifier, there's also the Docker file and the app.py and requirements.txt again. But I'm going to take a moment to look at what's in requirements.txt. Okay, so again, this is not a coordinated container web app, it's just one container. But it's still using Flask to listen to the browser port 8081. But the second line of this requirements.txt, remember, these are the libraries that are installed in the process of building the image. That is called transformers, and that's a special library that's built and maintained by the good people at Hugging Face. And it's basically a one-stop shop interface to all the models that they have. So you can use transformers with its various submodules and so forth to sort of grab and manipulate, pull down, and work with AI models. So moving on to the second command, it's a build. We're just simply going to build ResNet classifier. So we said Docker, whoops.
And more. Hide floating meeting panel.
So let's see, I was doing Docker build dash key for tag ResNet classifier. Oh. Then I forgot the dot. Using the stuff in this directory. So that was pretty quick. So because that ran so quickly, I have a feeling that it's kept the task of actually downloading the data to the run stage. In other words, the conversion from the image to the container. Let's see, Docker run dash -d. That's what our app is going to be called, ResNet. And then dash P, we're going to map 88. And I predict this is going to fail because I haven't stopped my other web app. It worked fine. So let's see. I'm going to take a moment to delete Prime Web and Prime API just for the sake of keeping the workspace tight. I'm going to say Docker remove dash -f. Docker remove dash -f. Prime API. And I say Docker yes. The ResNet is running. Okay, so now I go to localhost, but I type in port 8081 and see what it's. Let's see, HTTP. Cool, and it's got a ResNet 50 image classifier. Powered by interface. Choose file. Let's choose data. And the person in the picture was in fact wearing a hat. It's not a sombrero, but it was goofy looking. So because that thinks it was a sombrero. He's apparently wearing a bow tie. So it picked up on the hat. It didn't really tell us that there's a person there. Anyway, that's what I got. And I'll just take a minute for you to tire kick on this if you're interested.
I tried Docker container prune, but I still have those prime containers
That's because
In
they're
the
still
PS.
running.
still running. Do I need to remove them total?
Yeah, and the command for removing a Docker container is you say Docker rm space dash f, and then you give the name of the container.
But I did the container prune, so now it says no such container as prime checker.
Okay, so what happens if you do Docker ps?
Yeah, it shows that their status is up. Even though I did container prune.
Yeah, so the only stopped containers will be deleted when you do container prune.
Oh, okay.
So they're still up and running.
Yeah. We can stop them on Docker desktop.
Okay. Any port is fine. Any method that works.
They have little buttons.
But you should, my understanding is you should be able to delete them even though they're running using Docker RM space dash F. to make it one.
Yeah.
Okay. Anybody else managed to get this one?
Still building,
Still building.
still building.
Mine moved really fast, which means that that's what's sitting in the cache. I suppose.
When I try to classify it, it says the site cannot be reached.
The site cannot be reached.
Yeah, so I upload the image and I press the classify button. So instead of that page, it says site cannot be reached.
Okay, so I have a feeling that your application is not running. What happens if you say Docker PS? Is this the ResNet image classifier is running?
Same thing happening.
Okay, so if it's not running.
It is running at the start, and then when I press the button, it stops running.
Do you think it's because of the 8081
I tried it on port 8080 as well.
and it didn't work?
So
Browser. Mine works in Safari, but not Firefox.
Okay, yeah, I was using Firefox. Let me try Chrome.
I wasn't working in Chrome.
yeah, this is where I have to again plead that I'm a newcomer to this space also. So on one hand, I don't have an immediate command of like some of the debugging you can do. You can, for example, ask to see the logs for the things. But on the other hand, I did have a lot of luck debugging stuff by working with coding advice.
Same thing on Chrome.
Edge.
Edge.
Yep.
Working Edge.
The outlier. Yeah.
So,
I mean, it's Chromium at this point, so.
yeah, I know Microsoft stuff.
Mhm. Acquisition. Yeah, I put quotes up, you didn't see.
I can't get Safari to do anything. I don't know.
Slide in here that had some debugging stuff in it. I'm having a hard time finding it. Yeah, that was awesome. This is it.
Seems to 404 when I submit an image.
That's not good.
Which browser are you using, Rob?
I'm using Chrome.
It's probably some like. mm,
Okay, so just in case this is of interest, I mentioned logs. So the command is docker logs, logs, space, and then you give the name of the container, which in this case we named it ResNet. If you run that, then there might be some insight in the printout that you get, because it's basically talking about the traffic it's experienced. And if there's an error message here, you can simply paste that into the chat of a coding assistant like QDeveloper and see what it comes up with. So you said yours worked. And did yours work? Sure, we're testing this one.
Even when I like go to a less secure browsing method, then it still doesn't work. I don't know.
Okay, well, as
But I understand that it would work.
You forget it, right?
It's just whenever it hits that 404, it even like it stops my container. Like it's not running in Docker anymore. It's just like
Yeah. So it's
it's kind of interesting.
just catching fire and that's it. Okay, well, I'll try one more image just for the sake of display here. So I have a file called unicorn, which is a unicorn playing chess. And was it working? This is what it looks like. Apparently it's a unicorn is also a gazelle hound. Or Saluki. I guess ResNet is likely interested in dog breeds.
It thinks it's a
Yeah.
Tim town.
I can idea what it is.
Maybe there's no training image of a unicorn. I guess maybe. Why not?
It's like an Australian candy.
Oh. Like a really famous one.
So
Skylight Glacier. Ow. So, you know, at least it's consoling that we haven't particularly installed the most brilliant image classification model in the world. Okay, well, let me press on with my last couple slides here and then we can call it a day. And it will be my hope that you're interested enough in this that you'll like take a shot at debugging it if it wasn't working. So the part 7 image classifier Docker file is actually reproduced here with some highlights. So Workdir we've certainly seen before, that's just create a directory called app, and that's do everything. And then it copies from the host operating system project file requirements.txt. It copies that into that application.
Oh,
Yes.
it might be an Apple Silicon issue.
Hmm.
I just there's, but that's a,
Well, I do see a bunch of Macs out.
This one's Apple, so
I don't know.
Well, then there's processor.
it's an M two.
Okay. So then there's a couple of run commands here. Run commands build images. And the second one is what I really wanted to point out here, which is it's running -C, which means treat everything that follows this as a Python file. So in other words, there's no .py file, it's just some text that's interpreted. And it's pointing to the transformers library, importing auto model for image classification. And then it's using that object with a from pre-trained method to cite the Microsoft ResNet 50. So that sort of fourth command, that second run command there, is what's going out to the web and pulling down the high bytes models, getting all the data necessary. Okay, so I just wanted to point that out, and then move on. So summary and conclusions. My feeling is that once these containers become sort of second nature, then you sort of start to pivot into getting multiple containers to work together, and that's called, generally speaking, container orchestration. On one machine, like one host, you can use something called Docker Compose, and then on larger systems across multiple computers, you can use something like Kubernetes, and there's lots of technologies. So we're really just scratching the surface with this material. We use the Docker CLI for a bunch of different things, but the sort of four bread and butter commands are build to make an image. Create isn't used very much, but that creates, but doesn't actually run a container. Docker run starts from an image and then creates the container and then runs it. And Docker start just starts up an existing container. So hopefully my fast use of this terminology is like sort of kind of making sense. Yes.
Oh, I did just want to say another one to look into would be Docker push. And that's the one where you can take the Docker containers that you've created locally and push them into Docker Hub, where then you can pull them elsewhere or share that. It's kind of a way of publishing your Docker container there.
Right, and so to do that, you would actually have to do command Docker configure, which would then you enter your login.
Yeah,
You
login.
enter some credentials so that you can authenticate it, so that when you do the push, it gets up there.
Yep.
Cool. Again, a reference to the workshop that Kristen did with Aptainer and Silicon. Links to these things are all sitting in this documentation of this repo. And then I'm just sort of pointing out the fact that I certainly discovered lots of bumps along the way, just to my rudimentary knowledge that I generated to be able to get this far. And one of the things that Kristen's pointed out is that, like you're saying, with the processor architecture, there might be a crossover problem that some Docker image created to run on an ARM machine may fail when it gets onto an AMD processor. And so then there's this multi-platform building aspect of Docker, just to illustrate the bumps in the road that we run into. Okay, that's my last slide. So the ecosystem concept, lots of learning curves. It's interesting, and I found it to be kind of satisfying. It sort of worked once I got the hang of it, and I did a lot of hypothesis testing with the coding system. So we tried to do some from the ground up stuff today. Hopefully you found this of interest. And we have the other Aptainer workshop. I think you pointed out that a lot of the working on telecom, pulling images that were in Docker format, they were sort of automatically translated into Aptainer. So there's a compatibility built into this. Okay. Hiding face, coding assistance, orchestration, duality. And yeah, this is again, it's been UWIT research computing and in conjunction with that eScience Institute. So thank you so much for coming, and we'll stick around for a few minutes, and if you want to chat. So that's it.